So in this lesson, we're going to learn about remainder theorem. So you should have learned about long division before this. Now, the good thing about remainder theorem is that we can find the remainder without long division, okay? So often we go, okay, what's the remainder when this is divided into this? And we find the remainder. We use long division, but we can actually use this theorem, which is way quicker, and it will be asked a lot. So what is remainder theorem? Well, if a polynomial, px, is divided by x minus alpha, the remainder is p of alpha. Now some of you may get this, but I always find it best that we use an example and then we'll come back to this. All right, so this is an example we use for long division. Okay, we went through the process and we found out the remainder is 16. So we're going to use this as our test case. Now, what does a theorem say? If it's divided by x minus alpha, then the remainder is p of alpha. In this case, we divided by x minus 2, which means that 2 is alpha, okay? Yeah, according to the definition, all right? And that means that p of alpha should equal 16 in this case because that's the remainder, okay? Now we know that alpha is 2. So let's test it out. So what I'm going to do is I'm going to substitute what this alpha is, which is 2. So it's the opposite of the negative. So p of 2, and I'm going to substitute it into this one. So I'm assuming that this is p of x equals that, okay? So I am assuming, p of 2, and I'm going to substitute 2 into it because that's what remainder theorem tells me. Okay, and let's keep going. So we should get the answer of 16. So hopefully I'll do the maths right, okay? So we've got 3 times 2 to the power of 4, that's 16. And then we've got 4 times 8 plus 8 minus 8. So that's really good because we'll be able to cancel those already. So 3 groups of 16, so we're up to 32, 48 minus 4 times 8 is 32. And indeed, p of 2 gives us 16. All right, so if the question is just find the remainder, we want to use remainder theorem, okay? Just substitute this value in here, okay? So I'm going to use the second example that we used in class with this. So what would alpha be here? Well, alpha is 1. Okay, now I just want to make a little segue there because this is my last example with this. Is that what happens if we're dividing through by x plus 1? What would alpha be there? Well, alpha would equal minus 1. So if it's plus 1, we go negative, and because it's negative already, we go the positive. All right, so I'm just going to leave that there. Now, we're still going to use this. We've divided through not by plus 1, by minus 1, so there it is there, and we get a remainder of negative 7. All right, so I'm going to prove this again like we did with the last one, and that means that this is p of x is equal to that. So I'm going to go p of, and now I'm substituting 1. So let's have a look at it. 1 to the 4 plus 1 to the 3 minus 1 squared minus 5, 1 minus 3. So I've got 1 plus 1 minus 1. Well, those two will cancel out, won't they? So I've got 1 minus 8, which equals minus 7. Notice that remainder theorem gives us the remainder straight away. Okay, so if we're asked to find the remainder, just use remainder theorem. I want to touch on one more point. Okay, so what we've done here is essentially prove this, okay, that if we know what alpha is, we can find what the remainder is by substituting alpha in. Now, one of the benefits of remainder theorem is that we can actually find factors of a polynomial. Now, a polynomial can be like x to the power of 5, it can be x to the power of 100, it can be anything actually. We've already covered that. But I'm just going to go back to something simple. We're going to play magic numbers with this guy. So we've got factors of 6, all right, that have to add up to 5. And we've got 2 and 3. Okay, so therefore, we can factorize p of x as plus 2 and x plus 3. Okay. Now, what I'm going to do is I'm going to show you that if it has no remainder, then it's a factor. We know that this and this are factors of this. We know that. Hopefully we've known that for a couple of years. Okay. So if I substitute in an alpha of, say, minus 2, which is the opposite sign of plus 2, I should get 0 remainders because this is a factor. So let's do that. So I'm going to substitute minus 2 into it, into this one, into that. So I get minus 2 squared plus 5 minus 2 plus 6. And what I actually get, I get 4 minus 10 plus 6, which equals 0. Now, because that equals 0, now this is a chicken and the egg sort of thing, but it won't be the case. I can say, therefore, x plus 2 is a factor. All right. Now, if we wanted to do that with minus 3, you'll get the same thing. It should be 0. Okay. But if we substitute anything else, it won't be a factor because they're the only factors that we have. Anyway, that's the end of this video lesson. Peace out.